Welcome to VMware vDefend Security for VCF 5.x. This is the module on advanced threat prevention. My name is Chris McCain. I am a director at VMware by Broadcom, working specifically in the application networking and security division. This module is our official pivot into advanced threat prevention. So everything we've talked about before, with the exception of maybe early on, where we introduced some of the ATP, has really been about vDefend firewall. And now we're going to pivot into advanced threat prevention. So this is a very quick module, really just a refresher of some of the things we saw earlier on in the course, just to get you ramped up and ready for advanced threat prevention. Remember that VMware vDefend Security, built on top of our hypervisor, includes distributed firewall, gateway firewall. Those are the things we've been talking about so far. And then also advanced threat prevention. So here's where we'll start to dig deeper into our security technologies like IDS, IPS, that's intrusion detection and intrusion prevention, malware analysis and malware prevention, network traffic analysis, and then also network detection and response, which we can loop into the whole security analytics and management. So we've had an opportunity to talk about our security services platform. We've talked about the firewall. We've talked about intelligence. We talked about the gateway firewall. And so now we turn our attention to these deeper, more contextual security features in advanced threat prevention. If you look at the security features that we're offering as part of ATP in relationship to the way that these security features would be deployed in traditional fashion, so network-based firewalling, a physical firewall, often very manual or labor-intensive, rules that are built off of IP addresses or subnets. You have intrusion detection, intrusion prevention systems that lack environmental context, don't have a really strong east-west visibility, and then have a high false positive rate, again deployed historically as a physical device. And then with the insertion of a packet broker to be able to provide deeper inspection into the network traffic, you then have the ability to deploy additional physical devices using or performing network sandboxing. So a detection technology which is easily bypassed by evasive malware and oftentimes fails to detect advanced threats. And then finally, network traffic analysis, again, using physical devices, often difficult and costly to hairpin 100% of the traffic. So it's not an in-band type of inspection or enforcement. It's more an add-on to the architecture. And the NTA often results in high false positive rates. So just looking at this diagram alone, you can see these security features as being add-on pieces to the network as opposed to something that's really ingrained into the fabric of the architecture. So not built into the switches and routers, not built into the hypervisor, but added into the environment as additional physical devices. And that in and of itself is oftentimes where complexity comes into play. Detecting a complex attack. We've seen this slide before. We'll review it again. Looking at the security features we get through vDefend. So we've got our different tenants here, our orange and our green. We've got our tier 1 devices that provide firewalling capability and some additional malware detection and IDS IPS. And then for our individual virtual machines or virtual desktops, we have our firewalling, IDS IPS, NTA, NDR, all of the security features. So in just looking at this diagram, you can see the levels at which we can apply security. We're building a defense in-depth strategy by having these different enforcement points in the organization. So attackers and the attack stages they go through, we have the ability at multiple levels to mitigate their strategies. So we'll walk through here in their first step, Cobalt Strike download as part of the delivery attack stage. We've got our distributed malware detection and our gateway firewall malware detection to be able to help with that. Then we've got the Cobalt Strike, our C2, which is command and control traffic. We have distributed IDS IPS as well as gateway firewall IDPS to be able to mitigate. Vertical port scans as part of the discovery attack stage, which our network traffic analysis would be able to identify. So if you could think about it in terms of the attack chain, if an attacker gets into a virtual desktop and then starts running port scans, you have systems talking to each other that historically have not talked to each other, but are now being identified, or that traffic is being identified as, hey, this is anomalous traffic. So NTA can help in that space. Then we've got our lateral movement attack stage. We can also leverage NTA as a detector for this lateral movement. So we do have, and we have already talked about using the distributed firewall to help mitigate lateral movement. But when we're talking about the detection, the visibility into the attack chain, that visibility of lateral movement comes with NTA. And then we've got our dark side download, again, part of the delivery chain or delivery part of the attack chain. And we've got our distributed malware and gateway firewall malware detection there. And then finally, exfiltration, the exfiltration part of the attack stage. Again, we've got our IDPS to be able to detect the exfiltrations. And then finally, encryption. All right, so from a visibility perspective, what are the things that we need to know? What are the things that we're looking for? We have to understand applications on the network and their communication patterns. We have to understand if the current firewall constructs are correct and or effective. What types of microsegmentation, or we can even generalize that into what type of segmentation policies do I need? And then are these communications, these patterns, normal or abnormal? So keep in mind that data center networks host thousands of application components, and oftentimes it's a black box for the security teams. There's a significant lack of visibility. And so we've talked about this already earlier in the course, that owning the hypervisor, being able to draw analytics out of the hypervisor is a surefire way to get a richer set of data about the environment. So security intelligence, the visibility that we get, and you guys saw this when you went through the specific modules, but application flow visibility with rich context, eliminating blind spots, analytics and automation, so using the inventory and config to detect unprotected flows, workloads, and applications to get really good, high fidelity, efficient, best practice driven rule recommendations. And then finally, what we'll be getting into after this module is the AI and ML driven anomaly detection with NTA and NDR. So that data center under attack, all of the different points that threat actors want to be able to get through and get to, whether it's partners, contractors, support staff, consultants. Many organizations have these external entities which are often weak spots in the enterprise security because there's a necessary business case to allow these individuals to have access to resources within the network, but oftentimes can be difficult to control or understand and see what exactly is happening. So again, just a different way of looking at the attack chain. Malicious archive downloads coming from some external entity and then compromising a system, being able to discover other resources on the network, gaining credential access, moving laterally in the data center, exfiltrating data out of the data center, deleting shadow volumes and backups. Most attackers understand that there are technologies to help recover. And if they have the ability to find the shadow volumes and backups, that's a greater chance of somebody paying the ransom if the backup no longer exists. So they're learning to mitigate the strategies that we're putting in place to try and mitigate the malicious things that they're doing in the first place. It's this ongoing game of cat and mouse. So we have to continue to evolve our proactive security strategies to reduce the possibility that we need to use a reactive strategy like a restore. And then, of course, finally, double extortion with exfiltration and ransom. So that traditional IDS IPS approach drives up costs and complexity. Adoption is often limited due to the critical or regulatory mandated segments of the environment because that hairpinning of traffic can cause issues in the way applications perform. And oftentimes, application performance takes precedence over the security piece. So there's throughput constraints, there's selective traffic inspection, and there's lack of vMotion support or stale policies. The gateway IDPS. So we spent some time on gateway and understanding the gateway firewall and the use cases. Adding IDPS capability to the gateway means adding IDPS to the edge device that's getting deployed. Supported per tier 1 can detect and prevent intrusions at the network or the zone perimeter. Remember the use case of the gateway firewall being maybe I want to protect non-virtualized infrastructure. Maybe I want to use it to create my zones because my zones are made up of more than just virtualized workloads. So there's support here for all workloads, not just the virtual workloads, right? With the virtual workloads, you'd have distributed IDS, IPS. So Gateway can support the non-virtualized. It's the same signature set as the distributed, can be combined with decryption policies, and the same or different profiles can be applied between the distributed firewall and the gateway firewall. The malware detection and prevention is also enforced at 2 points. So we can enforce it in a more central manner on the T1 uplinks and service interfaces, which gives us malware detection only. And then we've got distributed. So for Windows and Linux VMs, we have both malware detection and malware prevention. So again, look at this as the opportunity to have a defense in-depth strategy where we can first look at it through the tier 1 device, and then we can look at it again through the distributed, or in cases where the traffic is not going through the tier 1 device, we are still protected because of the distributed architecture. So the two complement each other, the two supplement one each other, the two help build an overall stronger security posture. When it comes to network traffic analysis, building a baseline of normal is critical because we want to be able to detect attack techniques Say that 10 times fast. Detect attack techniques. Detect attack techniques. We want to be able to detect attack techniques by identifying security relevant anomalies without having to rely on the signatures. So IDS, IPS, malware detection, NTA, and then finally NDR. So the vDefend network detection and response. This is an advanced threat prevention platform that provides complete network visibility detection and prevention of sophisticated threats. So now we're bringing AI and ML not just into the analysis of anomalies, but because we have collected all of this data from across the private cloud, the artificial intelligence techniques that we apply can be used to analyze the network traffic and gain insights into traffic patterns that correlate into attack campaigns. So collect the information, see everything, analyze that information powered by AI, and then reply or provide that data back in a way that not only makes it easy to visualize, either through a map or through a timeline, but also giving you the ability to mitigate, to have some sort of response to this attack campaign in a way that helps recover or stop it from continuing to spread. All right, so that wraps up this module. This was just a quick review on advanced threat prevention. Thank you for joining.